Hi everyone. Today we are going to be talking about solving quadratic equations and interpreting the solution with respect to the corresponding relations. We are going to interpret real and non-real roots of quadratic equations through investigation using graphing technology and relate the roots to the x-intercepts of the corresponding relations. Okay, go ahead, grab a piece of paper and a pencil and let's get started. When determining the zeros, the roots, or the x-intercepts, using the quadratic formula, the part of the equation that is underneath the square root, or the radical, helps us to determine the number of zeros, or in other words, the nature of the roots. So let's just recap what the formula is for the quadratic formula. Okay, so hopefully you remember that it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and write that down in the space provided. Okay, there's our quadratic formula. The part that's underneath the radical is called the discriminant. So the b squared minus 4ac is called the discriminant. And this is how we're going to determine the nature of the roots. So let's look at a couple examples to see what I'm talking about. For our first example, y is equal to 2x squared, subtract 5x, subtract 1. Let's go ahead and use our quadratic formula and see how many answers we have, how many roots, how many zeros, how many x-intercepts. So remember, the 2 is the a, the negative 5 is the b, and the c is negative 1. So x equals negative b, so negative 5, plus or minus the square root, of b squared, so negative 5 squared, minus 4ac, so times 2, times negative 1, all over 2a, so all over 2 times 2. Next, we're going to go ahead and simplify. So negative times negative 5 is just positive 5, plus or minus the square root of 25 plus 4 times 2 times 1 is 8, divided by 2 times 2 is 4. Okay, let's keep going here. So x is equal to 5 plus or minus the square root of 25 plus 8, which is 33, divided by 4. So simplifying further, we have x is equal to 5 plus the square root of 33 over 4, and x is equal to 5 subtract 33 over 4. Let's go ahead and plug those into the calculator and see what we get. So x is equal to approximately 2.69, and x is equal to approximately negative 0.19. So this means that we have two solutions. So if you look at the discriminant, the part underneath the square root, if that number is greater than 1, we will have two solutions. So if you look under the square root here, we have 33. So 33 is greater than 1, so we have two solutions. Okay, let's look at our next example. Y is equal to x squared, subtract 30x plus 225. So same idea as before, let's determine our a, b, and c. So looking at the equation here, our a is 1, b is negative 30, and c is 225. So using the quadratic formula, we're going to substitute in those values. So x equals negative b, so that's 30, because a negative and a negative is a positive, plus or minus the square root of b squared, so negative 30 squared, minus 4, our a is 1, and c is 225. all divided by 2 times 1. All right, let's go ahead and simplify. Okay, so simplifying underneath the square root, so negative 300 squared is positive 900. 4 times 1 times 225 is 900. Divided by 2 times 1 is 2. So x is equal to 30 plus or minus 900 minus 900 is 0. Divided by 2, the square root of 0 is just 0. So simplifying here, we have x is equal to 30 divided by 2, and 30 divided by 2 we know is 15. So we have one solution, 1, 0, 1 x-intercept, 1 root. So if you look underneath the square root, if our discriminant, so the b squared minus 4ac is equal to 0, then we have 1 root. Okay, let's look at our next example. 3x squared plus 2x plus 15 is equal to 0. So again, our a is 3, b is 2, and c is 15, and we're going to go ahead and substitute into the quadratic formula. X equals negative 2 plus or minus the square root. B squared is 2, so 2 squared minus 4 times 3 times 15, all over 2 times 3. Okay, simplifying, we have negative 2 plus or minus the square root of 4, subtract 4 times 3 times 15 is 180, divided by 6. So x is equal to negative 2 plus or minus the square root of 4 minus 180 is negative 176, divided by 6. So if we take the square root of negative 176, what happened on your calculator? We get math error. So we can't actually take the square root of a negative number. So this means there are no solutions if the discriminant, so the b squared minus 4ac, is less than 1. Okay, next we are going to consolidate our learning about the discriminant. So if the discriminant is less than 0, we have no real roots. So remember, we can't take the square root of a negative number, we get math error. So no real roots, they're called. If the discriminant is equal to 0, we have one real root. If the discriminant is greater than 0, we have 2 real roots. So the reason that we call them real roots, so if we take the square root of a negative number, they're actually part of the complex number system, and we can take the square root of 176, ignore the negative, and then if we put a little lowercase I after the radical, that's telling us that we are now in the complex or the imaginary number system. Okay, let's look at an example here. So we're going to use the discriminant of the quadratic equation to determine the nature of the roots. So we're not going to use the quadratic formula this time, we're just going to use the b squared minus 4ac. So my a is 3, b is 7, c is 9. So b squared minus 4ac, substituting in our values, we have 7 squared minus 4 times 3 times 9 is equal to 49. Subtract 4 times 3 times 9 is 108. So 49 minus 108, we're going to get a negative answer. So negative 59. Because our discriminant is less than 0, we have no real roots. So we can check our solution with Desmos, so let's go ahead and do that. So I've gone over to Desmos and I've keyed in the equation y equals 3x squared plus 7x plus 9. And our parabola opens up and it is above the x-axis, so there are no x-intercepts. Or in other words, there are no roots. Okay, let's go back over and look at our next example. Example B, y is equal to 5x squared minus 8x minus 3. Again, we're just going to use the discriminant b squared minus 4ac, and we're going to determine the nature of the roots. So negative 8 squared minus 4 times 5 times negative 3 is equal to 64 plus 60. So that's 124. So my discriminant is greater than 0. So I know I have 2 real roots. Okay, let's go over to Desmos next and plug in our equation and see what we get. Okay, so plugging in the equation, we can see that our parabola opens up. The vertex is below the x-axis, so we're going to have 2 zeros. Okay, let's go back to our examples and look at example C. So our last example, we're going to use the discriminant to determine the nature of the roots for y equals 2x squared plus x subtract 3. So again, we have our a value, our b value, and our c value. So our b is 1, so 1 squared minus 4 times 2 times negative 3. So 1 plus 24 is equal to 25. So since the discriminant is greater than 0, we have 2 real roots. Okay, that's it for today. Thank you for your attention, everyone. Bye-bye.